Hello friends, next topic is Millet machine. Millet machine. Millet machine. What is the definition of the Millet machine? Each and every output is associated with the transitions. What is in Moore machine? Output is associated with the state. In Millet machine, output is associated with the transition. If output symbol if output symbol is associated with transition of finite state machine such automata is called as Millet machine. It's called as Millet machine. It covers the transitions for all strings over given alphabet What do you mean by this? Each and every state have exactly one transition on every input symbol. I have already told you Millet machine and Moore machine both are in deterministic in nature. Clear? For every input string it generate an equivalent output string. Clear? Next point. If the length of the input is n, length of input string is n, then length of the output string is n. If the length of the input string is n in Millet machine, then output length of the Milling machine is also n, but in case of Moore machine, output is n plus 1. Output is n plus 1. Please noted these points. Do fast. Next, we will see a specification of this. Okay. Specification of milling machine. Specification of milling machine. Milling machine. Machine M contains 6 tuples: Q, sigma, Q naught, delta, this delta, and lambda. What is Q? Set of finite state. Set of finite state. Sigma is input alphabet. Input alphabet. Q naught initial state. Q naught belongs to Q. Delta transition function. Transition function. What is delta? Q cross sigma determines Q. Clear? Next is this delta, output alphabet. That is finite. Lambda output function. Lambda depends on the state Q and input symbol. That is very important. In Milling machine, output is depends on the current state and input alphabet. But in case of Moore machine, output function depends on only current state. Clear? Please noted this. Okay, see next question. Example of Mealy machine. Construct a Mealy machine that generates an output X for every occurrence the input string every occurrence of a just wait, every occurrence of a in the input string otherwise it generate output Y consider input language is over the symbols of A and B. Please try to do this. Make the Mealy machine. In Mealy machine, output is associated with the transition function. See first question. Q naught. When we see A on Q naught, it prints X. When we see B on Q naught, it prints Y. When we see A on Q naught, it prints X. Otherwise, it prints Y. It prints Y. Clear? Clear? See, the transition table for this is very important. What is the transition table for this? Input A, output associated with the transition, input B, output associated with the transition. See, Q naught on A, Q naught on A, Q1 output is associated with A, Q naught on B, Q naught output is associated Y. Clear? Next, Q1. Q1 on A, Q1 output is associated, sorry, output is X. Output is X. Q1 on B, Q naught output is associated Y. Y. Clear? This is the transition table for Mealy machine. For Mealy machine. Is it clear to you? Okay, next question. See the next question. Construct a Mealy machine that generates an output X for every occurrence of AA in the input string, otherwise it generates output Y. Consider our input alphabet is AB. Please do fast. Yes, have you done this? Please check. Construct a Mealy machine that generates an output X for every occurrence of AA in the input string. Otherwise, it generate Y. See, Q naught seeing A, it produce Y. Seeing B, it produce X. Q1 seeing A, it produce X because A already gone. Clear? Clear? Seeing B, It produce y. Please see this. What is the transition table for this? Q naught, input alphabet is A, B. Seeing A, it goes to Q1, output is Y. Q naught seeing B, it goes to Q naught, output is X. Q1 seeing A, output is X. See, there are two outputs associated with the Q1, Q1Y, Q1X. In Moore machine, only one output is associated with the state. Q1 on B, it goes to Q naught, output is Y. Clear? Okay, do next question. Construct a milling machine that produce an output X for each occurrence of 0, 1 in the input string produces output Y for each occurrence of 1, 0, otherwise it generate output Z. Input alphabet is AB. Sorry, input alphabet 0, 1. Please try to do this. Do fast. Yes, have you done this? Take 1 or 2 minutes. Yes, see. Occurrence of 0, 1 input string x. 0, 1. It produce for 0, 1 produce x. 1, 0, 1, 0. It produce y. Otherwise it produce z. z. Now make the deterministic. This state have two transitions. There is a transition for 1 but not 0. Can I make the loop 0? Can I make the loop for 1? 1 z. This is the Mealy machine for given question. What is the transition table? Q naught on 0 on 1. Q naught on 0, Q1. Output is Z on 1, Q2. Output is Z. Q1 on 0, Q1. Output is Z. Q1 on 1, Q2. Output is X. Q2 on 0, Q1. Output is Y. Q2 on 1, Q2. Output is Z. Please see, what are the output associated with the states? Q1 के साथ in Q1 Z, Q1 Z, Q1 Y. What is the output associated with the Q2? Z, X. Clear? Next question. Construct the Mealy machine for 1's complement of a binary number. Construct the Mealy machine. Construct the Mealy machine for 1's complement of binary number. Please try to do this. Do fast. पांच दिया 15. Yes, have you done this? It's very easy. Only one state. 0, output is 1. If input is 0, output is 1. If input is 1, output is 0. This is the ones complement Mealy machine. This is a ones complement Mealy machine. Clear? How to write the transition table for this? Input 0, 1, next state, output, next state, output. A on 0, sorry, this one is Q naught. Q naught. Q naught on 0. Q naught. Output is 1. Q naught on 1. Q naught. Output is 0. Clear? Next. Construct the Mealy machine for the 2's complement of a binary number. Construct a Mealy machine for 2's complement of a binary number. For 2's complement of a binary number. Please try to do this. Do fast. See, when we find out the 2's complement and 1's complement, we assume that machine reads input from right hand side. Machine reads input from LSB to MSB, not for MSB to LSB. Okay. Zero one zero zero 100 100. What is the 2's complement of this? When we see 0, leave it as 0. When we see first one, leave it as it is 1. After that, complement the numbers 0 1 and 1 0. This is the Mealy machine for 2's complement. This is the Mealy machine for 2's complement. Clear? Write the transition table for this. What is the transition table for this? See. Next state, output, next state, output, input alphabet is 0, this is 1. Q naught on 0, Q naught output is 0. On 1, Q1 output is 1. On Q1, in Moore machine, we have 3 states for 2's complement. Q1 on 0, Q1 output is 0. On 1, Q1 output is, on 0 output is 1. On 1 output is 0. This is the transition table for that. Clear? Do next question. Construct a Mealy machine. Construct a Mealy machine that produce output A for every occurrence of 0 0 in an input binary string, otherwise produce B. For every occurrence of 0 0 it produce A, otherwise it produce B. Please do fast. Do fast. Okay. See, for 0 0 occurrence, it produce A, otherwise produce B. On 1, B. 0, A. On 1, produce B. Check. Construct the transition table for this. What is a transition table? Next state, output. Next state, output. Input is 0, input is 1. Q0. Q0 on 0, Q1, output is B. Q0 on 1, Q0, output is B. Q1 on 0, Q2, output is A. Q2 on 1, Q0, output is B. Q2 on 0, Q2, output is A. Q2 on 1, Q0, output is B. This is a transition table for that. Clear? In next video, we will see conversion of Moore machine to Mealy machine and Mealy machine to Moore machine.